Today we're going to talk about calculating our cerebral perfusion pressure, which is in short CPP. To calculate the CPP, our cerebral perfusion pressure, we need a few important numbers. First of all, we need the blood pressure of the patient. Blood pressure is a ratio of your systolic and your diastolic. As we all remember, systolic is when the heart's working, it's running, it's jumping, it's beating hard. And when the heart's relaxing, when that cardiac muscle is relaxing, it's in dystole, so that's your diastolic blood pressure. And pressure is commonly measured in millimeters of mercury. So to find that will help us determine the MAP, which is our mean arterial pressure. It's the average pressure that's being exerted. To find that, we need those numbers as well as our intracranial pressure. That's the pressure in the brain. A high pressure is not good. There's a low pressure because that means the brain's not doing what it needs to do to maintain our daily functions. So to calculate the CPP, we need our MAP, which we get from calculating with our blood pressure, and we need our intracranial pressure. So first we're going to calculate the MAP. When we calculate the MAP, then we're going to subtract that MAP from the intracranial pressure, and we have our cerebral perfusion pressure. And then we interpret the data. Is it low? Is it high? A low pressure means that there's not enough perfusion going on, so death is likely going to be imminent. And a high pressure is also not good as well. We also need to know our normal ranges, which when we interpret the data, we'll use that to determine. So first, we have a patient who just got brought up to the ICU. He was a train wreck. His intracranial pressure is high. He's hypotensive. But they forgot to give us some numbers. They forgot to tell me what the MAP was, and they forgot to tell me what the cerebral perfusion pressure is. So we're going to find that out using the information they give us. Always use our given information to go by what we have here. Don't overread it, don't overlook it, don't overthink it. So, first we're going to calculate our MAP. Using our MAP, the formula is the systolic blood pressure plus 2 times the diastolic blood pressure, and please use PEMDAS. So you're going to multiply, you're going to times your diastolic blood pressure times 2, add it to your systolic blood pressure, then you're going to divide by 3. So let's do that first. We have our blood pressure of 90/60. The patient's hypotensive. So I guess I got to give him some fluids, right? Or some vasopressor, something to kind of increase that blood pressure. It ain't looking good. So we're going to do our systolic blood pressure, which is 90. We are then going to plug into the formula. It's just like Algebra 1, plugging into the formula. Then we have 2 times our diastolic blood pressure, which is 60. And we're going to divide that into 3. So let's do that first. And that's our mean arterial pressure. So 2 times 60 is 120 plus 90. So we have our 90 plus 60 times 2 is 120. And then we're going to divide that over 3. And this simplifies to 210 over 3. And that becomes our mean arterial pressure is 70 millimeters of mercury. Usually, if the patient's normotensive, this is considered normal. So we're going to use that 70, as well as our intracranial pressure that we're given. So we're going to use that 70, our MAP of 70, and then we're going to subtract it from our intracranial pressure, which is 24. So then we have 70 minus 24, and that is 46 millimeters of mercury for our cerebral perfusion pressure. So that we have the data we need, we can interpret this. Our normal values for our intracranial pressure is 5 to 15. That means our intracranial pressure is increased. We then have our cerebral perfusion pressure is 60 to 100. I think of it like the normal sinus rhythm. The rate is 60 to 100. It's normal. Same for the cerebral perfusion pressure. The brain and heart are boyfriend and girlfriend. Or boyfriend and boyfriend. Or girlfriend and girlfriend. Or they them are theirs. It just all depends on how you want to look at it. I like to make real life applications. So 60 to 100. They're the same. They have everything in common. They're together. They're a happy couple. So, in our case, though, our cerebral perfusion pressure is 46. Our MAP was 70. This pressure is low. So that means there's not enough perfusion to the brain. Therefore, death will be imminent, and the following interventions, if you're reading your book, will have to be followed. Remember, your pressure is a whole number, guys, okay? That's it for calculating cerebral perfusion pressure.